What's up guys, and welcome to today's video. So in today's video I'm going to be showing you guys how we can interact with a smart contract that is already deployed, how we can make deposits and withdrawals from this smart contract, and also how we can attack this smart contract using Reentrancy and Foundry. So guys, if you have watched the first part of this video, or if you have watched my previous video, I want you to go to the 9th minute of this video. So just fast forward this video to the 9th minute of this video, then we can continue. So in this video, we are going to deploy a smart contract that is going to exploit that smart contract that's vulnerable, and we're going to see if we can actually drain all the money in this smart contract. Okay, so guys, so this is a detailed article of what we're going to do. Contract we are going to deploy is a bank contract. It receives Ethereum as deposit, and whoever sends the Ethereum can actually withdraw the Ethereum. So it works like a typical bank, just that it has no third party. It's just a smart contract and nobody's controlling it. It doesn't need any KYC. All you just have to do is to call the smart contract and send in your deposit, and whenever you need your money, you call in the smart contract and request a withdrawal, and it's going to send it to you. But guys, this smart contract is vulnerable. We're going to exploit that vulnerability, and also we are also going to secure this smart contract and try and see if we can exploit it again using Reentrancy, and it's supposed to fail, right? So this is the smart contract. This is the attack bank smart contracts that we're going to deploy to the Ethereum testnet and see if we can actually attack the already deployed smart contract and drain its funds. So just go ahead and start the process. So as you can see, this is the attack bank smart contract that we're going to use to attack the KONVATI bank smart contract. So this is the deployment script. This is the code we're going to write to Foundry. So we're going to make deposit to the bank, and we're also going to withdraw just to make sure this bank smart contract works, right? Then we're also going to attack it. So guys, we're going to start afresh. So we're just going to go to a new folder. Right, so guys, we are starting afresh from the beginning. I'm just going to show you guys step by step the process, right? So this is a new folder, and we are going to open this folder on a Visual Studio Code. Okay, so let's just copy this address and let's go to our command prompt. So let's change the directory to this address. So now we are inside this folder. So let's open our Visual Studio Code. I already have a video on how you can deploy a smart contract. I already had a video how you can deploy a smart contract using Foundry. So there I explained everything to you guys. So just go ahead and watch the video. So let's go. So this is the video how we can deploy a smart contract, but we're going to do the same thing again. So let's just continue. So I've opened our terminal in Visual Studio Code. So because this is Windows and we're using PowerShell, so we're just going to switch this. Let me close this. We're going to switch this to WSL. Perfect. So the first thing we want to do now, we want to create a Foundry project. So let's just write forge in it. As you can see, it's creating a Foundry project for us. It's going to create a test file and a source file. Okay, so we'll just allow it some time. So guys, once that is done, as you can see, it came with it gave us default script. We're just going to delete all of this because we're going to be uploading our own script. So let's go back to this. So the first thing we're going to do, we have to deploy our bank smart contract and actually interact with this bank smart contract. So we're going to deploy this bank smart contract konvati.sol. So let's just do that right away. So this is the smart contract. As you can see, it accepts deposit and it also withdraw deposit, but this smart contract is vulnerable to Reentrancy attack because of this. So let's try and see whether we can exploit this smart contract. So let's go to the deployment script. Let's copy the deployment script. let's go ahead and deploy our bank and let's test it, right? So how do we deploy this bank now? So we need an RPC node. So let's just create an environment. New file, just .env. And we're going to deploy our KONVATI bank smart contract and we're going to interact with it. So first and foremost, let's deploy this smart contract using Foundry. So this is the code we're going to put on Foundry and we're going to replace this with our RPC URL and we're going to add our private key. Let's just go back to my Visual Studio Code. So I'm just going to copy and paste this code and I'm going to hit enter. So it's compiling. As you can see, it's setting up the EVM. Okay. So we are deploying the smart contract code. That's very good. So the error was this. There was a typo error here. There was a typo error from this. So I'm going to correct this. So this was the typo error. That's how I've been getting so many errors. So now, guys, we have our bank. This bank contract is live. You can copy this address and you can check this transaction hash on the Sepolia testnet. So we're just going to copy this contract address because we're going to be interacting with this contract. Let's just go to environment. Let's just create a new KONVATI bank. So this is what we're going to do right now. We're going to check this smart contract if it's actually live. This smart contract is live. Okay, as you can see, it was deployed 1 minute ago and this is the transaction hash. So as you can see, transaction hash 6D9. As you can see, it's actually it's live. So we're going to interact with this smart contract, this KONVATI bank. As you can see, this KONVATI bank, it's a simple bank contract that accept deposits and withdraw. But this bank contract is vulnerable. But let's just let's try and send money to this contract, right? So let's come here. As you can see, we have some funds here, right? We have some Ethereum here. So let's try and see if we can actually send money to this smart contract. So let's get the smart contract code. So this is the code. Let's just copy this address and let's come here. Let's paste this address. As you can see, guys, it's not letting me send. As you can see, guys, it's not letting me. As you can see, guys, it's not letting me send money to this smart contract because the way it's designed, right? You can't send money to it. You can only deposit and you can withdraw. So how can we interact with this smart contract? How can we actually deposit this smart contract? Okay, so let's do that right away. So let's try and make a deposit of 0.001 ether, right? So how do we do that? Okay, so we're just going to copy this line of code and we're going to go to our Foundry and we're just going to paste this line of code. We're going to change this with the smart contract address. We're going to send 0.001 ether to this bank. Okay, for the purpose of this video, let's go to Etherscan. Let's copy the contract address, right, and let's paste it here. Perfect. So let's hit enter. We've successfully deposited money into the smart contract. So if you come here now, as you can see, the Ethereum balance is 0. So let's just refresh this. Okay, as you can see, guys, the balance has updated. Someone made a deposit. Okay, so let's go and let's go back to the account that made the deposit. That's this account. As you can see, the value of this account has reduced. And if we should copy this address, and we paste it here, right? Let's hit enter. You can see this is the balance. It's the same as this. And you can see it's made a deposit. It's made a deposit to this smart contract. That's our smart contract that we just created, A36. That's the smart contract A36. So that's why the balance is actually increased. And we can also withdraw this money. But let's use another account and also make this deposit. As you can see, this user made a deposit to that same smart contract of 0.008 ether. So if you come here and refresh this balance, it should be 8. As you can see, it's 9. So it's 8 plus 1, which is 9. So it received 1 and it also received 8. So let's test the withdraw function now. Okay, so let's try and withdraw 1 ether. This user that sent this 1 ether, let's try and see whether you can actually withdraw the money from this bank account. Okay, so how do we do that? So we're just going to come here and we're going to call the withdraw function, right? So let's just copy this withdraw function and let's go back to our Visual Studio Code, right? And I'm just going to paste this function here. So we're calling this function here. So this is the function that we're calling. We're calling the withdraw function, right? So this contract is supposed to send the user 3 back his 0.001 ether that he deposited into the bank smart contract. So let's just check that. So this balance is going to go to 0.008. Let's refresh it. As you can see, guys, it's now 0.008. Let's just refresh this again. So somebody actually took out 0.001 Ethereum from this smart contract. Okay. So now we're going to try and see if we can actually attack this smart contract and steal this balance. Okay, we're going to deploy a smart contract. What's this smart contract? And let's see whether we can actually steal this balance from this smart contract. You know, the only way you can actually take this money out is if you made a deposit. Now let's create a new smart contract to attack this smart contract and see if you can exploit this smart contract and be able to take this money that we did not deposit, right? Let's deploy this smart contract. Let's copy this smart contract. So this is the attack smart contract. Let's just copy it. Back. So let's come back here. Now we're going to create a new file. Perfect. So this is the smart contract that's going to attack. It's going to interact with this already deployed smart contract here. It's going to call the deposit function and it's going to call the withdraw function. And once it calls this withdraw function, this is the attack function. As you can see, it's going to send 0.001. Then it's going to withdraw the money immediately. Then it's going to check if there's still money in this KONVATI's bank account. If there's still money in that bank account, it's going to withdraw it. It's going to drain all the money and send it back to the owner, right? So this is the smart contract we're going to actually use to attack this smart contract. So let us also create a deployment script. Let's just duplicate this. So what we're going to do here, we're going to change this to the already deployed smart contracts, right? So let's go back to our already deployed smart contract. We're trying to drain this whole amount. So let's copy this and let's come here and let's paste this here, right? Perfect. So let's save this file. Right, and we're going to compile this smart contract code. So we're just going to write forge build or forge compile n1. So it was able to compile. So now we're going to deploy it. So let's just imagine a situation whereby user 2 is KONVATI, and let's say KONVATI, or let's just say user 2 is John, and let's just say John loves cryptocurrencies and John loves this bank project. John trusts this bank project with all his money, right? So John is going to send 0.04 to this smart contract. So John is literally going to send almost all his money, and we're going to see if user 3, the attacker, can steal John's money that is inside this KONVATI's bank account. Okay, so we're going to send 0.04 ether to that smart contract. Let's check the balance of this smart contract. As you can see, guys, this smart contract has way more balance right now. So let's try and see if we can attack and steal John's money from an attacker's account, which is this account. So this account has 0.0499. If this attack is going to be successful, this account should have 0.899, right? So let's try and do this attack. So we're going to go back to our Solidity code, and we're going to deploy this. We're going to deploy this smart contract to interact with this already deployed smart contract and attack it, try and drain all the funds, right? So how do we deploy this? Now we're deploying from the attacker's account, which is this guy, right? So let's copy his private key, which will be used to send the transaction. As you can see, guys, we have successfully deployed this smart contract, this attack smart contract that is going to attack our KONVATI bank and try and see if it can actually steal the money. So this is the smart contract code, right? We can check this. We can check this. So we can check this smart contract here. As you can see here, it was just deployed 33 seconds ago. So this smart contract is going to attack the other smart contract. It's going to attack the smart contract that has money in it, and it's going to send all the money to this guy, right? This guy. So this guy is our user 3. This guy is our attacker, right? So it's going to send all the money to this guy. So let's continue, right? So how do we go about it now? So we have done the deposit and we've done the withdrawal. So now we want to attack. So we're just going to copy this line of code, right? So we're going to go back to our Visual Studio Code and we're going to paste this line of code. So what it's actually doing is that he's calling the attack function. It's calling this attack function, right? And this function has a callback. It's going to receive the callback and keep withdrawing the money in this smart contract. So there is no more money in the game. So we are going to pass in user 3's private key here. So let's just get that. This is the private key. But you know what? Just get it directly from his account. We're going to paste it here. We're going to put in our RPC node. We are going to send 0.001 Ethereum, right? Because that's how we're going to do the attack. If we send more than that, the attack is going to fail. And we are going to put in the we're going to put in this new address, this new smart contract address, because that's the contract we're going to interact with. So let's just come here and let's delete this. So guys, let's cross our fingers and see what will happen and see whether we were able. Oh no. As you can see, guys, it's reverted. So somehow we were unable to attack this vulnerable smart contract. I don't know why it's not working. Maybe it's a test net. I'm still going to test it again and see if we can actually try and steal this amount of money. As you can see, let's go back here. As you can see, the money is still in this vulnerable smart contract, or let's say it's not vulnerable, but just refresh this page. As you can see, it's still here, and we are unable to attack the smart contract. And this user that actually trusted user 2, right? That's John. They actually trusted the smart contract and sent all his money to the smart contract. It's safe, so he can actually withdraw his money, which we're going to do that in this video. If you have any idea, or if you know the reason why it didn't work, let me know in the comment section below. But let's try and see if this user can actually take his money out of this smart contract. That's by calling the withdraw function. We'll paste this here. Then let's get his private key. We're just gonna, user 3 has noticed that that smart contract is vulnerable, and luckily for him, the attacker was unable to drain it. So what is he going to do? He's going to quickly withdraw his money before someone else drains his money, right? So let's pass in our superior procedure, and we're going to pass in our smart contract, the KONVATI bank smart contract. Copy, and we're going to paste it here. Perfect. And let us hit enter. Okay, it's giving an error. What's the error? Okay, we did not put the $sign. Let's put the $sign. As you can see, guys, it was successful. So let's go back to this account and let us refresh this page. As you can see, guys, he was able to get back his money. You see, the smart contract is actually secured for now. Okay, let's go back to the smart contract and let's refresh it. Let's check the balance. 0 Ether. So user 3 was able to withdraw all his money. As you can see, this was the function that he called the withdrawal function, and he withdrew all his money from this smart contract. So now the attacker failed to capitalize on this vulnerability, and the user was smart enough to remove his money, right? So as you can see, this smart contract is definitely vulnerable, but I don't know why I cannot I'm coming, give me a second. So we're just going to paste this whole smart contract here. We're going to save it. So this is the same smart contract, and this is our Slater tool, right? So let's run Slater. So this is the vulnerability, and as you can see, Slater has seen the smart contract. Reentrancy in KONVATI.withdraw, KONVATI right? So is either our code is not good enough, or there's something that we didn't do right. So I'm going to end this video right here, and I'm going to run some tests, and when I find the error, I'm going to be making a new video. But guys, what we learned how to deploy a smart contract. We also learned how to interact with this smart contract. So you cannot just directly call this smart contract with your MetaMask wallet or with any wallet to send money to this smart contract, because it's not going to receive it. You can only just call the deposit function and the withdrawal function. Okay, if you want to contact me, just head over to konvati.com/contact, or you can just come to the website. You can join our Discord, or you can book a session with me. I can go through your code. I can analyze your code for any vulnerability, and you can just contact me here, or head over to konvati.com/withdraw. If you like this video, give this video a thumbs up. If you don't like this video, give this video a thumbs down, but let me know the rating in the comment section. See you guys in the next video.